Today we're talking about polyatomic ions. Now what's really important in that phrase, I know polyatomic is probably the thing that's standing out, but the word ion. So everything we know about ion nomenclature is going to be brought back and we're going to be using that again. So keep that in mind, that what we know about ions is important. And along with that, in sort of that standard list of all previous nomenclature stays the same, and it's true, all previous nomenclature stays the same, and behind me is the list of previous nomenclature that we've done. And if you're counting up how many things we've done and how many things are on, or what number was here, I know that I'm a little bit out of number. My numbers aren't making a whole lot of sense, but the way we do things in class follow this, or this follows the way we do things in class. All right, let's talk about polyatomic ions, and first of all, decide what that is. And the most the easiest way to think about it is it's a group of atoms, that's the polyatomic part, that has an overall charge, the ion part. So it's a group of atoms with a charge. So how we deal with a single atom with a charge and how we deal with polyatomic, multiple atoms or groups of atoms with a charge, will actually be fairly similar, but of course there are unique things about it. And if you were looking at a list of polyatomic ions, and there should have been one where you found this video, if you found it on our class site, otherwise you would have gotten it in class, otherwise, yeah, we'll figure something out. But all of those polyatomic ions on that list have a single name. No matter how many atoms are in that group, they have one single name. And most of them, not all, but a lot of them anyway, contain oxygen atoms, but the oxygen is not specifically identified as part of the name. So if you think about, say, chloride, well, it contains chlorine, sulfide, sulfur. But for some of the polyatomic ions that contain oxygen, you won't hear any kind of oxo, you won't hear the sound telling you that oxygen is in there. And that also means that, or I shouldn't say it also means, but the other thing about polyatomic ions is that the endings are different. So we aren't going to end them all with IDE as we had before. Now we're going to use ate and ite. And the ate and ite will also help us keep track of how many oxygens there are, sort of. Okay, so you don't have to write this list down. Again, all of these are on that polyatomic ion list, and if you don't have that list, this is not anywhere close to being complete. Really what I wanted to do with this, though, is point out that here's a list of polyatomic ions. They all have an ionic charge. It's not always the easiest to see. They also all have a single name. So even though there's sort of a main atom and then some oxygen atoms, they all are identified by that one atom. The other thing is, except with the exception of ammonium, although ammonium is one of the few polyatomic ions that's a positive charge. But we range back and forth between ate and ite in most cases. Okay, a couple of other things to keep in mind. Everything we know about ionic nomenclature applies to here. So when we're using metals that never take a Roman numeral, still don't. If we're using metals that do require a Roman numeral, they still do. If we're using metals that could go with those weird alchemist Latin names, they still can. And everything else like that. Total positive charge, total negative charge, all of those rules that we needed to use for ionic nomenclature, we still need them. And I've got this line here, and at first glance, the idea that some little numbers don't apply may seem kind of weird, but if I give you an example, and I should have used a different one because I've got 3 showing up twice, but if you look at the Na3, obviously, I think, it means that we've got 3 atoms of sodium, Na. But if you look at the PO3, that represents a phosphite. That represents one unit of that group, phosphite. And the 3 is part of the group. So in other words, PO3 counts as one thing. So yeah, there's 4 atoms, and yes, inside that group that 3 means something. But other than that, I don't have 3 phosphite groups. I only have 1 group of phosphite. So what happens if I do need more than one of those clusters? Well, then I put the cluster, the polyatomic ion, in brackets, and put a number outside of that and say I've got more of those groups. So the PO3, if I had more groups, I would handle it like this, put it outside the brackets. Now, you might be wondering, well, could I multiply that little number in? And the short answer is yes, but if you did that and had P2O6, you wouldn't recognize it as a phosphite, so we don't. And one of the things that we had about polyatomic ions, sorry, not polyatomic ions, but ionic nomenclature, was crossover and reduce. We're always looking for the lowest possible terms, the lowest possible ratio. And that's still sort of true, except there are a few polyatomic ions that mathematically could be reduced, but we don't do that. So here I could reduce that a little bit farther, but if I did, I would lose the recognition of the polyatomic ion. So I have to keep at least one complete ion, and if that ion has a ratio that could mathematically be reduced, I won't reduce it. Okay, so you've seen a couple of examples. How do we use it as nomenclature? Short answer, just like ionic nomenclature. So if you had an example like this, you would start with exactly the same way. We always started with a negative ion, and you'd figure out the total negative charge. Now again, if you didn't write down that list of ions and there's no expectation for it, and you don't have a polyatomic ion sheet with you, take my word for it, the BrO2 ion, it's called bromite, that ion has a charge of -1. If there's a 4 outside the brackets, that means I have 4 of them. Total negative charge, -4. That means that the total positive charge has to be +4. Now, of course, I could turn that into a Roman numeral, but just to do some other nomenclature that we've already done, +4 represents the higher charge of tin, Sn, so that means I could identify using stannic, and I would call it stannic bromite. And again, if you don't have the polyatomic ion sheet, you're going to have to take my word for it that that is the correct name for that polyatomic ion. Going from a name to a formula, same thing as before. I know what the formulas are, I know what the symbols are, and I know what the charges are. And again, I'd have to refer to a polyatomic ion list, but I would cross over and attempt to reduce. And if I can't reduce, then I leave it like that. And again, there's no reason to bring those, to multiply the little 2 on the far end inside, because I want to count the number of groups rather than try to isolate atoms. Okay, a few last things. Number one is when you're doing your handwritten stuff, it's important to be careful now, because I have names that end in IDE, ITE, and ATE. So if you're a little bit messy, then I need to be able to see what you're writing. You need to be able to see what you're writing. It's just that simple. The name is still only going to have 2 parts. So in this example here, I've got a lot of atoms. I've got 3 different kinds of atoms, but I still have a 2-part name. So resist the urge to start identifying the oxygen as a thing. We'll talk in class. Hope this helped.